Today we're going to work on rational equations and radical equations. Now, we've done rational expressions and radical expressions, but today we're going to throw an equal sign in there and we're going to actually solve them. Okay. We're going to start with rational equations. Rational equation it's just an equation that contains a rational expression. Okay? Something like no, I'm not finished. Same goal as with any other equation. I need to solve for x. I need to get x by itself. I need to isolate the variable. I need to get the x by itself. Okay? Before I can do that, there's actually a couple ways we can go about this. Two different ways. Well, there's a bunch of different ways. I can start off by trying to get all of this as one fraction, like get a common denominator here and have this all as one fraction. So I have like this. I have two equal ratios. Because what do we know about solving two equal ratios? Two equal ratios, what do we know about their cross products? They're equal, right? Cross products are equal. So if you can get it to look like that, that's great. That's fantastic. You could cross multiply and you have no more fractions. So that's wonderful. Except that I have this pesky 5 right here, so I really don't want to have to deal with that. Since both of these are exactly the same, x minus 3 and x minus 3, I could just multiply everything times x minus 3. And then what will happen? Yeah, like if I have 1 over 8 and I multiply times 8, what happens to those 8s? They cancel, right? So I'm going to try to multiply everything times x minus 3. Well, over here, when I multiply times x minus 3, what happens? It's just x, so it's cancel out, right? Equals. Now, this, I have to multiply x minus 3 times this one, and times that one. What happens when I multiply it times this one? It's just 9. What happens when I multiply it times this one? Right. Plus 15. Exactly. 4 equals 24 minus 5x. And then what do I do? Okay. 6x equals 24. Exactly. 5 by 6. X equals 4. Okay. That's easy, right? Yes. Sure. I'm not tricking you. That's easy. Yeah. I mean, and now watch this. No, it's not true. Okay, keep that one on your paper to look at. I'm going to give you another one to try by yourself. Okay. So keep looking at that one so you have an example. 1 plus x over x minus 5 equals 5. So right there, what's that? And right there. Okay. At 5. So at 2x equals 10. That's easy enough, right? Let me show you one of the other ones that I was talking about.
On that, would that be undefined since you can't take out the 0? No, when you actually plug it in.
When you plug it in the original equation, it would have no clue. If it was the original, it would be an answer. Yeah, because you really can't put it back in there. Yep. All right. So. All right, check this one out. This is the one I was telling you about earlier. This is a ratio. This is a ratio. They are equal. That makes them proportions. Remember, in a proportion, cross products are equal. So that means 7 times x is equal to x plus 12. Cross products are equal. Subtract x. Yep. 6x equals 12. X is 2. Yeah. It can be a little bit uglier. I'm going to show you one that's a little bit uglier, but it's still not bad. You have this one written down? X over x minus 5 equals x plus 7. Okay, so cross products are still equal. There's a little bit more to these cross products. That means x times x plus 1 equals x minus 5 times x plus 7. X squared plus x equals x squared plus 7x minus 5x minus 35. What happens here when I start moving stuff around? Yeah, x squared's cancel. So you look at this and you go, great, I have to factor again. I can't remember how to factor. No, you don't, because they're going to cancel out. And you end up with a negative x equals a negative 35, or x is 35. These aren't so bad, right? Sometimes I do just for fun, but this isn't really much fun. So let's look at radical equations. Those were rational equations. Now let's look at radical equations. these can get a little ugly. We're not going to do the absolutely hideous ones yet. Yeah, we'll get there. This one's pretty simple. I'm taking the square root. So you square each side. Yes. X plus 4 equals 9. And then what do I do? You subtract 4. Yes. X equals 5. So I'm going to do it for yeah, well, they can. Now, on these, you do need to start getting in the habit of checking them. I don't think so much the ones we're going to do today, because I'm going to, until we take the test, I'm going to steer you just to the easier ones. But we could get solutions that aren't really solutions on these, okay? So, but 5 works. Okay, they can look a little different. Like we can have fractional exponents. Can you just give me an easy way to start? Let's say we have x to the 2/3 equals 60. Okay. Now, a fractional exponent is a root and a power. It's like saying I'm taking the 3rd root of x and I'm squaring it. It could also look like this. You see that? You can write it like that, okay? But because of the power to a power rule, remember a power to a power, you multiply the powers. Remember that? If I have like x squared to the 5th, that would be x to the 10th, right? Okay, so because of the power to a power rule, you multiply the powers. In order to get rid of that, I just need to take it to another power that will, when I multiply it and get rid of it, will equal 1. So what can I multiply 2/3 times to make it equal 1? 3 halves, yes. I multiply times 3 halves. 2/3 times 3 halves is 1. Now, if I'm going to do 3 halves over here, if I'm taking this side of the 3 halves power, what has to happen over here? 3 halves power. Yeah. So x equals, I think it's 64, but you might put that in your calculator. What's 16 to the 3 halves? Is it 64? I'm gonna add a little something to that in just a second, but I want to make sure. Does everyone see how 16 became 64? Even if you break it up, the half says take the square root. What's the square root of 16? 4. And the 3 says to cube it. So 4 times 4 times 4. That's how we got 64, right? Okay, so let me ask you this question though. When I take 16 to the 1/2 power, is 4 the only answer that I get? Isn't there another one that would get 16? Yeah, -4. Good job. Yeah. See, I knew y'all knew that. Because -4 times -4 is 16, right? Okay. So, when I took the square root of 16, which is what the 2 told me to do, the answer could have been 4, but it also could have been -4. So if it was 4, yeah, my answer is 64. But what if it had been -4? It would be -64. So on your answer, like this, if there's a possibility that it could have been a positive or a negative, you need to have a plus or a minus on your answer. Okay? gonna let you write that down, and we're gonna talk about it again for just a minute. Okay, well, I need to do that if I'm taking like odd number groups, like third powers, a third of something. Well, I need it on those. Like if I have 27 to the 1/3 power, that's 3. Is there a chance that it was a negative 3? What's negative 3 times negative 3 times negative 3? Negative 27. So do I need to do it on odd number denominators? No. You need to do it on even number denominators though. Because if it was an even number, a second root, a fourth root, a sixth root, then you've got an even amount of negatives being multiplied, and a negative times a negative is going to make it a positive. So if you've got one of those even number roots, you're going to have to do this plus or minus thing on it. Okay? Alright. I'm going to give you 2. I'm going to add a little something to them. 2x 4/5 minus 27 equals, that's 47, not a 27. You're going to get a horrible answer. Okay, what do I need to do first over here? Add 47. And that's what? 162 divided by 2. 1. Now x at the power is isolated, so I'm going to take this to 5/4. 243. Is it going to be plus or minus? It's a what? Because it's an even denominator. That could be 3 that got me there, but it could also be a negative 3 that got me there. So I have to put plus or minus, because a positive 3 to the 5th power is 243, but a negative 3 to the 5th power is negative 243. Alright, what's first over here? So I have 5x to the 3/4 equals 40. Divide by 5. X to the 3/4 equals 8. Go to the 4/3. 4/3. X equals 16. Do I need a plus or minus? No, it had to be a positive 2 that got us there, which is 16. Yes. Okay. If it's an even number denominator, you need a plus or minus. If it's an odd number denominator, you can just leave it with the answer how it is.